All right, hello everybody. Thank you for watching our video. Today we will be explaining the question you're all wondering. What is optics?
So what is optics? How did you use it today?
So the first thing I did is I woke up to the sound of my alarm clock, which had a LCD display, which told me the time.
I use my phone as an alarm, but it has the same sort of display on it.
Oh, cool. Then since I woke up, I couldn't see, so I put on my glasses.
I don't need glasses. I just walked into my bathroom and looked in the mirror.
Oh, nice.
Hmm.
Then I made breakfast. I had some leftover waffles, which I heated up in the microwave, which uses optics.
I didn't do breakfast. I didn't have time. I just hopped into my car and turned on my headlights, which also uses optics.
So you can see we use optics all the time in even the smallest ways, and we'll go into that a little bit more. So optics is, in simple terms, it's getting light from point A to point B.
Now I have a laser on me.
So point A and point B could be from the Earth to space, or it could be even short distances, like from my eyes to my glasses. And when moving light from point A to point B, we can use lasers or other light sources. We also have assistance from things like lenses, which are, for example, either your glasses, or if you have a camera that you could put a lens on, that's also optics. And then we also use fiber optics, which are essentially little pieces, skinny pieces of glass, which can transport light, which transports information. So when most people think about optics, they think of glasses, but that's actually only a very small part of optics.
So optics is big. Here at the U of A, we build and polish up to 8.5 meter mirrors. In this image, you can actually see people standing behind the mirror. Interesting fact, for an 8.5 meter mirror, you can actually fit about 6 or 7 children across it, or upwards of 4 adults if you lay down and ignore protocols.
Yeah, very big. Optics is also very small. So when we're testing mirrors, sometimes we use these things called lens arrays. They're very small, maybe a square centimeter, and on that tiny little thing, we fit 1,600 tiny lenses, so very, very small. We also use microscopes, which are optics that can be used to see very small things, even electron microscopes, which can be used to see an atom.
So optics is fast. The speed of light is about 300 million meters per second. What this means is that light can travel around Earth 300 times in a single second.
Wow, that's really fast. Since we were talking about how fast the speed of light is, sometimes we want to slow that down, and we use this thing called the Bose-Einstein condensate. It's the coldest thing in the universe, and we can use it to speed down light from that really fast speed you were talking about to about the speed of a Volkswagen.
This goes pretty slow.
Yeah.
So optics is near. Here we have an image from a scanning tunneling microscope here at OSC. These microscopes can get close enough to resolve single individual atoms. This image is actually a C60, which is 60 carbon atoms all formed together to look something like a soccer ball.
Optics is far. So we already talked about how optics can be used in telescopes to see things in space. Some things we're doing at U of A in that is we helped with the Hubble Space Telescope, and in this picture you can see a galaxy that we found 12 billion light years distant, very, very far. And we also contributed to some of that discovery for the out of focus problems the Hubble Space Telescope was having.
So optics is new. In this, you can see that someone is using a VR headset to play their video games. These are becoming more and more popular and actually use very refined optical systems.
Yeah, and even though we think about those new things like VR headsets, this is actually something we've been using for a very long time. In 1609, Galileo built this telescope that you can see, and he used it to discover 4 of Jupiter's moons.
Optics is challenging, big business, and booming.
Yeah, optics is very exciting. We see it a lot of different places. For example, communications, whether you're in the car listening to the radio, Medical equipment, so if you break your leg and you go into the doctor's office, they'll use an X-ray to take a picture of that. That uses optics. Also telescopes, like I was talking about earlier, looking at the stars or other things. Spy satellites. Cameras, this could be like even the one in your pocket on your phone. This is optics. Display technology, like your television set. And satellite and GPS, so when you're lost and you open the Google Maps app, this actually uses the GPS technology. And also research and education, which is a lot of the stuff we're doing here at the University of Arizona.
So here are some cool images of just other uses for optics. You can see everything from stuff that happens in the ocean to cool detectors to medical devices. And my personal favorite is in the bottom right, you can see someone holding their little pet lizard, and that's actually using an infrared camera.
Yeah, so I hope you all will consider joining us here at the College of Optical Sciences at U of A. It's one of the best programs across the nation. We have about 120 undergraduate students, and our average class size is about 30 students. So you get that hands-on approach. Thank you.
Thank you.